Hello everyone. This is Mistress Sweet Pea again with another podcast. I hope everyone is doing fabuloso, and just I hope everyone's doing well. Anyways, I've got a R2D2 here with me today, and he wanted to chill with me, so I said, hey, why not? Because today's podcast is about something he's probably going to be interested in. But and I also have my Zen as well, you know, the one with the little rake, and supposed to try to calm you. Let me tell you, I wish I had this yesterday, because today's podcast is going to be about something that I found out about my car yesterday that I don't know if many people know, but if you do, that's great, because I didn't know. Anyways, today's podcast is going to be about CVT car transmissions. Yeah, I know, I'm the mistress of tech, but we're going to do something different today, because yesterday I wish I had this to calm my nerves. So, anyways, my car is, I have a Nissan Versa, 2020 Nissan Versa, and when I accelerate, my car, it's like it sticks, like it doesn't, you know how with remote, excuse me, you know how with an automatic transmission, it when you give it the gas, it's supposed to like accelerate and then switch gears automatically. It does it, but it's kind of sticking a little bit. So I figured, you know what, great idea to do a podcast about it. The story of CVT car transmissions. And, you know, I hope everyone enjoys this podcast, because maybe you learned something, but you know what? I definitely learned something. So, we're going to go ahead and get started. R2 is ready to join as well. So, the story of CVT car transmissions. A CVT is a type of automatic transmission. It basically finds used fixed gears. Instead of using a pair of pulleys or a belt, sometimes a serpentine belt or a chain, to provide an infinite range of gear ratios. Basically what that means is that your engine can stay in the most efficient speed range no matter how fast you're going. I apologize. I had some hot chocolate earlier and it went down the wrong way, and it's still affecting me, so sorry about that. So basically, what's happening is when you press on the accelerator, the pulleys move closer together or further apart, and what that does is that it changes the effectiveness of the diameter of the belt. So this smooth, stepless shift gives a seamless driving experience, but yet on me, it's giving like a jerk effect to it. So basically, what I did was I called around and inquired about, like, hey, I have this car, I'm having this problem, what do you suggest? Of course, everyone's going to tell you what they think, which is fine. I'm all for it. I'm all for advice. So, this gentleman here in town gave me some great advice, and he told me it probably is not your engine, it's probably I didn't realize my 2020 Nissan Versa is a hybrid car. I know you're probably thinking, wow, where the hell has this girl been? How did she not know this? Well, I honestly don't, because I'm not a car person. So apparently I've got a hybrid car that I didn't know I had. But anyways, it's just, he told me that it's probably, I need to put some sort of a chemical solution. They called it like an injection solution into your tank, and then fill up your tank afterwards. It's supposed to clean out all the erosion and corroded stuff that's in there in your tank, I guess, or transmission. So I did buy something. I'm gonna try it today. I'll see what happens. Fingers crossed my car works. So anyways, going back, I digress. So going back to the podcast, believe it or not, CVTs, they're not a new invention, I found out when I was doing my research. The first CVT was developed in 1879 by Milton Reeves for use in sawmills. So I guess by 1896, Reeves was fitting CVTs to his cars, and other manufacturers, other companies started to follow suit like he did. CVTs didn't become mainstream in cars until much later. So basically, in the automotive world, it was decades afterwards that they started using them. A Dutch company called DAF, D-A-F, was one of the first to popularize CVTs in the 1950s. And then later, other brands like Nissan, Honda, Toyota, they all embraced the technology, and especially for hybrids, where efficiency is key. So, again, CVT is continually variable transmission. That's what the acronym stands for. But for the purposes of this podcast, I'm just going to say CVT. It's easier, and sometimes I get lazy and I don't really want to say all that. Try saying that really fast. So the history of CVTs in cars is a long, bumpy road that stretches from the Renaissance sketches to the modern Formula One and millions of compact cars that are on the road today. So again, this concept was, it didn't impact cars till decades later. In the U.S., Milton Reeves invented this, and other manufacturers caught on, other car companies caught on to this. And for anyone out there that doesn't realize, check and see if you have a hybrid, because I did not realize I had a hybrid. And when I bought this car, wow, I'd say like 4 years ago, they told me it was just automatic transmission car. They told me that it wasn't, obviously it's not electric, but they just said it's just a fuel efficiency car, just regular gas, 87 or 91. You want to go premium or you want to go regular unleaded? And no, not one mention. Even the manual, it doesn't reference anything about a hybrid. And I read that manual. That manual is this thick, maybe give or take. I read it. I didn't see anything in there. But then again, who knows? So, the real turning point for CVTs in mass production of cars came in the 50s again, and Hub Van Dam was one of the manufacturers, along with the company DAF, D-A-F. So in 1958, DAF introduced the DAF 600, which was a small car equipped with variomatic transmission, which used a belt run in between two variable diameter pulleys. Like the way the guy explained it to me, it's like a serpentine belt. He said he thought at first the serpentine belt was going. Could have been, but I don't know. I am going to take it in eventually, but. So anyways, the variomatic layout, which is a belt driven between two pulleys whose effective diameter changes to create a continuous variable ratio. Because the blueprint for most modern CVTs, it became the blueprint for most modern CVTs. DAF kept the CVT in his cars until the passenger cars division was sold. And Van Dam went on to become Van Dam Transmissions, VDT, which developed the steel push belts used later in CVTs. All these VTs, CVTs, DVDs. It's like, I love the acronyms. Okay, so a little history here. The first modern CVTs. So the CVT reappeared in mainstream automotive world in the late 1980s with the Subaru Justy. I don't know if you guys remember that car. I vaguely remember hearing about it or seeing a commercial about it. It was okay. Not something that I would run out and buy if I was at that age. But in 1987, Subaru introduced its first electronic controlled steel belted CVT as an option on the Justy model in Japan. It was supplied by Van Dorn's technology, and it was followed by a four-wheel drive version that they established in 1988, and Justy became the first production car widely available with a CVT. shortly after other manufacturers started to follow suit. So Ford and Fiat used steel-belted CVTs in the Fiesta and Uno back in '87, and also Jatco, which is Nissan's transmission arm, offered CVTs in its Nissan March and Cube from 1992. Remember those Cube cars? Gosh, those were cute. I like those. I don't know why I didn't buy one. My first car was a Pontiac Sunfire. Again, no disrespect against Pontiac, but not my. I was what I could afford at the time. But those Cube cars, those Cube little cars were so cute. Anyways, in 1996, Honda introduced its pulley-based Honda Multimatic, and the CVT it was a 6th generation CVT with the Civic, and it had a multi-plate clutch instead of a torque converter to stop idle creep. Stop idle creep. That sounds like something a woman would say to a guy. Anyways, I'm digressing here. So, moving on forward, CVTs. So, in regards to more CVTs, the cutaway model of a Toyota K Super CVT showed internal components. In the U.S., the first production car with a CVT was the Justy in 1989. And in the 2000s, we also had other models as well, like the Nissan Murano and Altima. They started incorporating the CVTs. Honda continued to refine its CVT with the Civic, CR-V, and Accord, while Toyota developed its own CVT for the Corolla, Camry, and hybrids. Also, CVTs were also tested and used in Formula One racing in the early 1990s, with teams realizing that a CVT could keep the engine in its ideal power for maximum acceleration. This gave a measurable performance advantage, but it was also controversial because it made the cars feel unnatural and threatened the balance of the competition. And so it made it feel like one car was, because this car had a CVT and it was like the car with the CVT was performing better than the other ones, and it made it seem like, okay, well, this car we know is going to win because of its CVT and its performance. So I can understand that happening. However, between 1993 and 1995, FIA regulations effectively banned CVTs from F1, limited transmissions to a fixed number of gears. I believe it's either 6, 7, or 8 gears. I don't remember the exact, and my research for this did not indicate which one. So it's either the first 6 gears, the later 7, or the later 8 gears. I'm not sure. The story is that there was a classic tech tale. The CVT was so good that it made the engine work efficiently that it was deemed unfair and had to be restricted. So people thought that car with the CVT had a fair advantage over the ones that didn't, and they didn't feel that it wasn't fair for the other cars that didn't have that CVT. So in today's world, today's CVTs are standard equipment in most economy and compact cars like Hondas, Toyota, Nissan, Subarus, Hyundais, and even Kias, and are especially common in hybrids where efficiency is critical. Modern CVTs are much more reliable and responsive than early versions, with software that stimulates steps so the car doesn't feel like it's droning at high RPMs or revolutions per minute. So looking ahead, CVTs are evolving into what they're called e-CVTs, electronic CVTs, used in many hybrid and plug-in hybrid systems where an electronic motor and planetary gear set combine to create a continuous variable effect without traditional belt and pulley setup. So while the classic CVT may not be in every sports car, it's out there. It remains a key part of how many of us drive cars with CVTs every day. And there's some that don't. But there are pros and cons of CVT transmissions. The good aspect of it is that it gives better fuel efficiency. That's one of the biggest advantages of CVT transmissions is fuel efficiency. That's why CVTs are so common in hybrids and in economy cars. I can't even talk to. They squeeze out significantly better mileage than a traditional automatic transmission with the same engine. Also, another positive aspect of this type of transmission is that it's smoother, seamless driving. Their CVTs are famous for being known as a smooth drive. There's no gear shifts, there's no shift shock, there's no jerking when you accelerate or cruising. So that is one of the beauties of these CVTs. Also, it's a simpler design and lower weight. So they have few moving parts than a conventional automatic transmission. No complex gear trains, clutch packets, or multiple planetary sets. Also, good low-end power for city driving. So a car with a CVT is great for driving in the city. Since it can hold the optimal rate, it doesn't need to hunt for gears like an old four-speed transmission does. Also, better emissions and fleet compliance. CVTs improve fuel economy, which means that when you go have your car inspection, depending on what state you live in, some states don't have emissions inspections. But if you're in one of those states that does, these CVTs will also help with your emissions. It also makes automakers meet strict emission and fuel economy regulations that they're required to meet. Now, as with the upscale, the downscale of CVT transmissions is unpleasant driving feel and sound. The most common complaint about these CVTs is consumers are saying how it feels and the sound of it. So when you accelerate hard, the engine can rev up and stay at a high rate. And then if you look at your dashboard, your RPM is still high while the car is still building speed instead of the traditional rev, shift pattern. So like with my car that I'm having issues with, that's what's happening. It's when I accelerate, it still accelerates. Sometimes it jerks, but it just stays high. And it's like, I have to tap on the brake to slow it down. It's basically the feel and the sound of it, I'm not a fan of. And it's weird because I've had this car for a couple of years now and I'm just now noticing that. So that's interesting, I guess. Perceived throttle delay and rubber band effect. Many drivers notice a slight lag or hesitation when matching the accelerator, especially from a stop. So like when I'm stopped with my car, I'm using my car as an example, so I'm going through that right now. When I stop, it's fine, but when the light turns green and I give it the gas to go, it's like jerks a little bit, and it doesn't do it all the time. So it's like the effect of it. It's like a sluggish feeling. It feels like the car is sluggish, like it's like, oh, it's going up, and then I want to go back again, kind of feeling. This type of delay is more noticeable in lower powered cars where it can feel like the engine is revving high, but the car is slow to respond. The other thing is limited torque and towing capacity. So CVTs are generally not designed for high torque engines or heavy towing. A steel belt and pulley system can only handle so much before it starts to slip, which is why you rarely see CVTs in performance sedans. So, I learned a lot doing research on this because there's so much that I had no idea. The other downfall of CVTs is the repair. This is the one that's going to get me. The repair cost. So modern CVTs are much more reliable than the early versions, but they still have a mixed reputation. Some brands have widespread CVT problems. And again, and that when I was doing my research, exactly, I'm going to read it verbatim what I found. It says here, while modern CVTs are reliable, they still have mixed reputation. Some brands, okay, I'm going to quote, some brands, notably certain Nissan models from the 2000s and early 2010s, have widespread problems leading to early failures, slippage, and full transmission replacements. That's because I've got a 2020. So I have a funny feeling my car is going to be quite expensive to fix. Maybe I should start a GoFundMe. No, I'm just kidding. I wouldn't do that. But anyways, so when a CVT does fail, repairs are usually expensive because the entire unit is often replaced. So it's not like they could just, take out whatever apart. They gotta take the transmission out of my car. And for those of you that don't know, and I'm gonna off topic here for a minute about cars, is newer cars don't have the dipstick option to check your transmission fluid. Like if you've got a car from like the 80s or maybe even early 90s, there used to be an option where you could, there was a dipstick for the transmission where you could literally check your transmission fluid to see if you're low or what. The 2020 Nissan Versa, you can't check it. There's no way to check it. You have to literally put your car up on a device and have it, pushed up, and have a repair guy or gal look down and look and check it to see what your transmission fluid is like. So I thought when you had an oil change that they checked the transmission fluid. Silly me, I didn't know. Now I know. And another negative about CVTs is high maintenance requirements. CVTs demand strict maintenance. They require special CVT fluids, and fluids must be changed at specific intervals. So in my car I'm over 100,000 miles, and so I know that mine needs to be changed. So that's going to be quite interesting. The other thing is psychological resistance and resale. Some drivers simply never get used to CVTs, especially if they're used to traditional gear changes. That can make a CVT car feel less desirable or used. So CVTs can become more common, and manufacturers refine their behavior with launches and better software equipment to help with that. But I don't know. If I had my way, I'd take a car from the 80s any day. So if we go into CVTs are a great choice if you want the maximum fuel economy, especially if you live in the city or highway, or if you do a lot of city or highway commuting. You like a smooth, comfortable ride without shifting gears, and you're driving a hybrid small car where efficiency matters more. That would be a great choice for a CVT. It's less ideal if you plan to tow heavy loads regularly or if you're an aggressive driver. So you're buying an older, high mileage CVT model with a known track record, but it's the value. It has very little fuel efficiency with certain cars. So not every car has the same fuel efficiency. So basically, a test drive is the best way to decide if you're buying a car. Do a test drive. Obviously, you do a test drive to see how it feels, how it performs. I would ask the dealer about if the car has a CVT. Maybe do some research before you go check it out. I wish I would have known that years ago before I bought my car, but it's a challenge. Anyways, so the future CVTs, they're found in many hybrids. As automakers focus on efficiency and electrification, CVTs will likely remain a key part of the automotive world. New innovations like e-CVTs are starting to increase, especially in hybrids, and they're pushing the technology even further. So who knows what the future will bring with CVTs, but we do know that they're not going anywhere, and they're going to be around for a long time. It's just a matter of, eventually there's no way to get around it. The CVTs are here. But what you can do is, again, like we normally do when we buy a car, we test drive it, get the feel of it. Maybe drive it again on a different day and see how that feels on a different day. I would definitely do as much test driving as you possibly can. And on that note, I want to thank everyone for tuning in today. And I'm sorry for the coughing. I'm just a little congested today. So thank you for bearing with me. And I hope everyone has a great day. And I hope everyone just please smile. Please be kind to each other. And have a great day.